Hi, and welcome to this video on solving systems of equations using the substitution method. Solving a system of equations is considering two or more equations and finding the point or points at which they intersect. If you're considering linear equations, then there will be only one point of intersection, unless the lines are parallel, in which case there would be 0 points of intersection. If you're considering equations of a higher degree, there may be more points of intersection. There are 4 methods of solving system of equations: graphing, substitution, elimination, and matrix. Today we will focus on the substitution method, specifically in regards to two linear equations. When using the substitution method, we are going to substitute one of our variables with an expression using the other variable. What do I mean exactly? Well, you want to solve one of your equations so that either x or y is by itself on one side, and then plug that expression into your other equation and solve from there. Let's look at a few examples to see what I'm talking about. Our first step is to make one of our equations have either an x or a y by itself on one side. For this example, we've already been given an equation like that. X equals 2y plus 7, so we won't have to do any extra manipulating. Now we want to think for a minute about what the equal sign means. The equal sign is telling us that the values on either side of the equation equals the other side. They're the same. So in our example, x is the same as 2y plus 7. Knowing that, we can then substitute 2y plus 7 in for x in our second equation, like this. 2 times 2y plus 7 plus 3y equals 14. Now we are left with only one variable in our equation, so we can follow the normal steps of solving an equation to find out what our y value is. 4y plus 14 plus 3y is equal to 14. So 4y plus 3y is 7y plus 14 equals 14. If we subtract 14 from both sides, we get 7y equals 0. And when we divide by 7 on both sides, we're left with y equals 0. Remember, solving a system of equations means finding the point where the two equations intersect. That means that we only have half of our answer. Our y-coordinate for this point is 0, but we still need to find our x-coordinate. We do this by substituting our newly found y value in for y in either of our original equations and solving for x. I'm going to use our first equation because it will take less manipulating to get our x. So x is equal to 2 times 0 plus 7, which is equal to 0 plus 7, or 7. So our x-coordinate for this point is 7. That means our final answer, the point of intersection for these two lines, is 7, 0. Let's look at another example so we can get some more practice using this method. Neither one of our equations is set up where x or y is on one side by itself, so we're going to have to manipulate one of them to make it that way. I'm going to solve our first equation for y. So we have 9x minus 3y equals 12. I'm going to subtract 9x from both sides. Gives me negative 3y equals negative 9x plus 12. And then divide by negative 3 on both sides, which gives us y equals 3x minus 4. Now we can substitute this expression in for y in our other equation. So negative 6x plus 8 times 3x minus 4 equals 4. Negative 6x plus 24x minus 32 equals 4. Now when we add these two together, we get 18x minus 32 equals 4. Add 32 to both sides. We get 18x equals 36. Divide by 18 on both sides. And we get x is equal to 2. Now that we have our x value, we can plug this number into the equation we found for y earlier to get our y value. So y equals 3 times 2 minus 4, which is equal to 6 minus 4, or 2. So our final point is 2, 2. Before I ask you to try one more on your own, let's do one more example together. First, solve one of the equations so there's an independent variable on one side. I'm going to solve the second equation for y. Now, we plug in this expression for y in our first equation and solve for x. Finally, we plug in our x value to our equation for y and solve for y. So our final point is 5/2, 2. Now that we've gone through 3 examples together, I want you to try one on your own. After I give you the equations, pause the video and try to solve it on your own. Then, once you have your answer, press play and see if it matches up with mine. Ready to check your answer? First, we want to solve one of our equations for an independent variable. I'm going to solve the first equation for x. Now, substitute this expression into the second equation. Then, plug the y value into the equation for x and solve for the x-coordinate. So our final answer for the system of equations is 2, 1. We only looked at examples with 2 linear equations, but this method can be used for more than 2 equations and for equations with higher degrees. Simply follow the same steps covered in this video. Solve equations for independent variables and then substitute them into the other equations until you get a singular variable to solve for. Once you have that variable known, work backward to find all the other variables. I hope this review of the substitution method was helpful. Thanks for watching and happy studying.